So now we are going to understand the basics of modular arithmetic and this group theory. Okay. So modular arithmetic equation. Right. I have introduced this equation in the introduction. I attributed this to Gauss. Yeah, we got this notation from Gauss. This actually means A is equal to Q times N plus B. So I have to note that all these elements, right, A, B, N and Q, all of them are integers. Okay, all of them belongs to the integer set. They are like either positive or negative numbers. Okay, we are not interested in decimals, right? Decimals or real numbers. We are not going to discuss that. We are only going to work with integers. So in this equation, it's not very useful unless we make some restriction. Okay, so unless we do this restriction, something like this: A is congruent to R mod N. So here R stands for remainder. Here this B does not actually have to be a remainder. It could be any other thing. For example, A could be 2, right? And we can say that 2 is congruent to 7 mod 5. We also can say that 2 is congruent to 12 mod 5 and so on. Okay. But this we don't want to we want to be specific. Then only we can make some useful progress. So in order to do that, what we will do is we will restrict the value of R to be strictly less than N and greater than or equal to 0. In short, we restrict R to be a positive number less than N. Okay, non-negative number, because 0 is not positive. Right. So let's start with some example. The Z5 set. Okay, so this is a set of 5 elements: 0, 1, 2, 3 and 4. So these are not actually integers. Okay, so they denote, let's say, a class of numbers. So this symbol 0 dash, it denotes set of all numbers which are divisible by 5. Okay, so which means 0 plus -5 plus -10 and so on. Similarly, 1 denotes set of all numbers which when divided by 5 gives you the remainder 1. Okay, 1, 6, 11. And what about the negative counterpart? Whether -1 belongs to this hat? The answer is no. Why? Because -1 can be written as 1 times 5, -1 times 5 plus 4. This 4, it satisfies this property. 4 is strictly less than 5 and it is greater than or equal to 0. So 4 is a valid remainder, which means -1 actually belongs to this class 4 dash. You can verify that the negative numbers of this type, okay, -4, -9 and so on. So these numbers have the remainder 1 plus 1, because -4 can be written as -1 times 5 plus 1. Okay. Yeah. So what is this group? This group is an abstract mathematical a structure. Okay, so it requires a set G. We denote this set as G and this binary operation. Okay, so this binary operation, it could be anything, right? But for our interest, we will only focus on addition and multiplication of integers. Okay, so this closure means for any x comma y in this set G, if you take any x and y from this set G, x star y will also be an element of G. Associativity means if we take any 3 elements from this set G, x star y, if we compute this and then z, this should be equal to x operated with y star z. This property will, this property is a certainly useful property, because if this property is satisfied, then we can do some optimization in code. Okay. So identity means it is like existential property, which means this requires that there exists, that's how it is read, there exists an element E, right, from this set G. Okay, these are like some abstract variables, these could be anything, okay, such that if you operate E to the left of x, should be equal to when you operate E to the right of x, and this should be equal to x. The order of these things might not mean like much more significance to you if you have not studied like advanced level mathematics, but there are certain operations where if you change the order, the result will differ. Okay, but since we are only dealing with simple integers, like we will always get the same answer if we are multiplying to the left or to the right. Okay, and inverse. So inverse means it is for all x in G. For every x in G, there exists an x inverse from G, from the same set, such that x star x inverse should be equal to x inverse star x. So both of them should be equal to the identity element E. So if a set under this operation, it could be either addition or multiplication, satisfies all these four properties, we will say that that set is a group under that particular operation. Okay. So why do we need the identity and inverse? Because we need to undo something, right? Think about it. You are encrypting a piece of text, you want to undo that operation. That is this mathematical inverse. Even in the signature scheme, you need this inverse to actually verify that the signature originates from the valid secret key. Okay. Now let's take a look at this Z5 group under addition. I'll denote it this way, Z5 under addition. So here we have this 0, 1, 2, 3 and 4. I'm going to ignore the dash, right? So we can simply work with these as if it is actual integers. So what is 2 plus 4? It is not 6, it is 1, because 2 plus 4 is 6, which when divided by 5, it gives us the remainder 1. We are only interested in the remainders. It is exactly like clockwork, the example that I showed in the introduction. Take a look at your clock. After a certain point, the pattern repeats, periodic repetition. So 4 plus 4 will be 8, but its remainder under 5 is 3, and so on. Of course, 0 will be the identity, because anything plus 0, you can safely say that you get the same number. What about the inverses? Okay, so if you observe 4, which belongs to the set, what should be the inverse of 4? Because 4 plus something, we need to get the identity element. So the identity element under addition is 0, because anything plus 0 will give the same number, right? Any x plus 0 gives us the same x. So 1 is the additive inverse of 4. Similarly, 4 is the additive inverse of 1. Okay, so if you observe this definition, if x inverse is inverse of x, x will be the inverse of x inverse. Okay. Yeah. And what will be the additive inverse of 2? That should be 3. 2 plus 3 is equal to 0. Okay, because it is 5, it is divisible by 5, so it's 0. Alright. Now the multiplicative group. I denote this using this symbol. So this set contains only 4 elements. It does not contain the element 0, because 0 does not have multiplicative inverse. If you multiply 0 to anything, you get 0. You will not get the identity element 1. And in this group definition, okay, all these 4 properties should be satisfied. And the fourth property says that every element in G should have the inverse. So under multiplication, 0 does not have the inverse, so we ignore the 0 here, right? So multiplication 2 times 4 should be 3 because 8, right? 3 times 4, 12, which is remainder is 2 when divided by 5. Similarly, 4 times 4 should be 16, remainder is 1. What about the inverses? As you can observe, the identity element is 1, so the inverse of 4 is 4 itself. For 2, it should be 3 because 2 times 3 is 6. So 6 is 1, right? So the inverse of 3 is also 2, and so on. 1 is the identity element, so 1 times 1 is 1. Okay, so that's how it works. Now the part of symbolic reasoning, right? So let's consider this set Z6. Okay, so Z6 means we are only interested in the remainders of 6. So if you divide, let's say, if you divide 30 by 6, you will get the remainder 0. 31, you get the remainder 1. 32, you get the remainder 2. 33, 3. 34, 4, because 6 times 5 is 30, right? And 35, 5. And 36, the remainder is 0 again. Okay, so you have like 6 remainders. Now the question is whether the 0 from Z5 is equal to 0 from Z6. The answer is it makes no sense to compare them. Of course, they are not equal because here the 0 denotes all the numbers of the form, all the numbers which are divisible by 6, which would be like 0 plus or minus 6 plus or minus 12 and so on. Here this 0 from Z5 represents all the numbers which are divisible by 5. They are like completely different. Does not make sense. So when we are like trying to understand the abstract math, the advanced level maths which are like used in the modern cryptography, it will be better if we use symbolic reasoning. Right, symbolic reasoning. We are not like stuck with the numbers, right? So we try to understand what does that particular number or that symbol means. So if you keep that in mind, it will be much easier to understand the advanced text.